Okay, so this is the midterm review. Now we have two reviews that we're going to go over. This will be the first of the two, and then we'll get to the next one here in a little bit. So what we're going to start with is 30, 60, 90, and 45, 45, 90, which are special right triangles. Why they're special is because they have a special, what is it called? Ratio between the sides. X squared root 2 means that the two sides across from the 45-degree mark are congruent, and they're also the smallest side. And to get the hypotenuse, all you gotta do is take the smallest side and multiply it by the square root of 2. Same thing with 30, 60, 90. Is anything across from the 30 is going to be your smallest side. The thing that's across from the 60 will be your larger side, but this will be x square root 3, meaning you take the smaller side, you multiply by the square root of 3, and 2x is our hypotenuse. That's the thing that is the longest side, all right? It's also always going to be across from the 90-degree mark. Now I'm only going to do a couple of these, and then I'm going to have you guys try these on your own. First thing is the 45, 45, 90. I'm going to do this one, and I'm going to do this one because these are the two separate different ones that you need to be able to do. 26. If we notice, 26 is across from the 90-degree mark. That means we have the hypotenuse here. So we look up here, what's in the hypotenuse's spot? Well, it's x squared 2. So what we're going to do is we're going to take this 26. We're going to set it equal to x square root of 2. Okay? Now, x square root of 2 is just like any number. We can multiply, divide, do anything with it. So that's what we're going to have to do in order to get rid of the square root of 2 next to the x, because we're trying to get the smallest side here. And in order to do that, we need to get rid of this. So to do that, we need to divide out because they're multiplying. Okay? We're at that point. Now you get 26 over the square root of 2. Normally this would be your answer, okay? But because we can't have a radical in the bottom of a fraction, we need to multiply the top and the bottom by the square root of 2. The reason is what I'm going to do here is I'm going to make this bottom part a perfect root, so I won't have a root down here anymore. How you do that is you multiply the top and bottom by whatever number is right here. So we'll multiply the top by 26 times the square root of 2. It becomes the 26 square root of 2. And then I'm going to multiply square root of 2 times square root of 2. Since these are both under a square root, you multiply them together. So it would be 2 times 2, which gives us 4. Well, the square root of 4 is actually 2. So it's 26 square root of 2 over 2. And if you take 26 and you divide that by 2, because this can actually be reduced, we get 13 square root of 2. Alright? What this is, again, is the smallest side. We just found the smallest side, so this side right here is 13 square root of 2, and this one here is 13 square root of 2. The reason is because they're the smallest sides, or the value which is just x. So you just put them right there. This next one, we can notice that this 11 is across from the 45-degree mark. This one was across from the 90, this one's a 45, so this one's actually a lot easier than you think. Let's go to a reference triangle. What's across from a 45-degree? An x. So we automatically know x equals 11. So we know x equals 11. That means we know this side up here also has to be 11. Why? Because it is also across from a 45. You know these two sides are going to be the same in a 45, 45, 90 triangle. The last one, all right, you just take x, whatever x is, and you multiply it by the square root of 2. So in this case, we're going to take 11 and multiply it by the square root of 2. All right? Since this is on the outside and this is on the inside, we can't do anything beyond that, so we just keep it as 11 square root of 2. So that's our two answers. All right? Now, This next one we know is the hypotenuse, so this will be like the first one. So I'm just going to tell you the answers. This one will end up being 16 square root of 2. This one right here is like the 11, so you'll know this is 9, and you'll know this is 9 square root 2. This is 17, okay? Then we know this is across from this. Now, the whole process, when you get here, you'll end up with something like this. You'll get 17 square root 2 over 2. In these before ones, 26 could be divided by 2. 26 divided by 2 gave you 13. In this one, this is not an even break. You can't take 17 divided by 2. So what we're going to do is we're going to just leave it like that. So that should be your answer. And finally, this last one is just going to be 6 square root of 2. And that's it. Alright, this next part. Okay, so we're going to go back and forth, but I'm going to do this first, this second, and this third triangle up here. Okay, so this first triangle, what we're trying to do is we're always trying to find the smallest side. The smallest side with a 30, 60, 90 triangle is the one across from the 30 degree. So in this case, it's going to be what y it becomes. First, we've got to look at what we know. We know the hypotenuse is 20. So we go back to our reference triangle, which is right here. We know the hypotenuse should always be equal to 2x, or 2 times the smaller side. So I'm going to set 20 equal to 2x, and then I'm going to solve. I'm going to divide by 2 on both sides. You're going to get x equals 10. What that means is that we just got the smallest side, which is y. So you know y equals 10. Alright? The next one, to get z, we have to take the smallest side and multiply it by the square root of 3. So in this case, the smallest side we just figured out was 10. So to get z, we take 10 and multiply it by the square root of 3. Well, we can't do anything with that, so it just is 10 square root of 3. And that's it. This next one, alright, so right now, you can see that we actually now already have the smallest side. So if you have the smallest side already, what you can do is you can just take that smallest side. To get the hypotenuse, you multiply it by 2. So in this case, it'll be 6 times 2. And then you can, to get the longer side, you can take 6 and multiply it by the square root of 3. Okay? So this becomes 2 times 6, which is 12. That's it. This one up here will be 6 times the square root of 3, which equals 6 square root 3. And that's it. Finally, this last one, this is across from the 60-degree mark. So let's look at the 60-degree mark. What is that? Well, it's x square root of 3. So we're going to solve this like so. We're going to set 15 equal to x square root 3. We need to get x by itself, so we have to divide by the square root of 3. Just like in the problems with 45, 45, 90, we cannot have a square root in the bottom. So what we have to do is we have to multiply the top and the bottom by what's right here, which is the square root of 3. This gives you 15 square root 3 over the square root of 9, which square root of 9 is actually just 3. The next step is to check, can we take this? Is it divisible by 3? Well, 15 divided by 3 is 5, so yes. So you end up with 5 with the square root of 3. Now remember, this is the smallest side, so this is the y in this case. Okay? And in order to find this side, we just got to take the smallest side and multiply by 2. So 2 times 5 square root 3 Well, we only can multiply the outside numbers together, so 2 times 5 gives us 10. And that's it. And I'm going to give you the answers to these next. This should be 11 square root 3, and this should be 22. This should be 13, and this should be 13 square root 2. And finally, this is 6. This should be 2 square root 3. This should be 4 square root 3. Okay, those are the 45, 45, 90 triangles. Now what we're going to get to is the acute, obtuse, and right triangles. So acute, obtuse, and right triangles. I'm only going to do a couple of these just to show you what to do. So we know the formulas for a Pythagorean theorem is a squared plus b squared equals c squared. And we know that for right triangles. But sometimes you can have obtuse triangles. If you take a squared plus b squared and it's greater than c squared, you know that's acute. Or if a squared plus b squared is less than c squared, it's obtuse. So, with this first one, what you can tell is, let's find the biggest number. This is the biggest number, so this is going to be our C, this will be our A, this will be our B. Okay? So we'll take 66 squared plus 94 squared equals 210 squared. Actually, I'm going to put a little line here because we don't actually know if it's equal or what it is. So if we take 66 and square it, we get 4,356. Plus, if you take 94 and square it, you get 8,836. And then finally, if you take 210 and square it, you get 44,100. So, I already know off the bat, if I add these two together, it's going to be less than this. So this is going to be an obtuse triangle. Okay? Let's try this one right here. So this one will be the biggest, which will be C. Actually, no, let's try this one right here. Alright? C is always going to be the biggest thing. It doesn't always have to be in the bottom. It's just going to be the biggest number. This is going to be B. This is going to be A. Okay? So you should get 115 squared plus 252 squared equals, or not equals, but 277. So what you'll end up with is 115 squared is 13,225. 252 squared is 63504. And then 277 squared is 76729. So what you'll get is when you add these two together, you'll get 76729 equals 76729. So you know that they're going to be equal to each other, so this will be a right triangle. Okay? Alright. This next one right here. We're going to use the Pythagorean theorem to find the third side, and we're going to have to reduce our radical. So, remember, the hypotenuse is always across from the right angle if you have a right triangle. So this is going to be the hypotenuse, or C. This will be A, this will be B. Okay? So we'll get 12 squared, or A squared, sorry, plus 12 squared equals 16 squared. So this will be A squared plus 144 equals 256. Now we have to get A squared by itself, so we subtract 144 from both sides. We get A squared equals 112. Now in order to get 112 by itself, we have to square root the A squared. So this is what I mean by reducing a radical. We have the square root of 112. This isn't a perfect root, meaning it doesn't create a whole number when you square root it. So what you have to do is you have to break it down to its prime factors. So this will be 56 and 2. This will be 23 and 2. All right, I can't break 23 down anymore. So what I can do is I can write out the list of factors. So it's 2 times 2 times 23. Now, I have a pair of 2's here, all right? What that means is it's technically 4, and the square root of 4 is 2. So they come out as a single 2. What's left over is the 23 because it doesn't have a pair to come out with. So your answer would be 2 square root of 23. And then I'm going to do this one. We know A, B, but we don't know C. So I'll give you 10 squared plus 15 squared equals C squared, or 100, plus 225 equals C squared, or this will be 325 equals C squared. Square root both sides, you get, and then we got to break this down, all right? I know 25 goes into that, so that'll be 13 and 5, or 25, sorry. And 25 breaks down into 5 and 5. So there's our primes. So this would be 5 times 5 times 13. The only two numbers that are alike are the 5, so they come out as a single 5. The 13 stays back, like so. And that's it. That's how you find the third side and reduce the radical. The last part is the distance formula. Okay? So, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So what I'm going to do is I'm going to first look at these 2 points. What are these 2 points? Well, this one is 5, 2, or negative 5, 2. And this one is 7, negative 3. Okay? So I know the negative 5 is my first x. I know the 7 is my second x. I know the 2 is my first y. And I know the negative 3 is my second y. So this is the order we're going to put it in. It says x2 minus x1. So x2 is 7 minus x1, which is negative 5. Plus negative 3 minus 2. We're going to end up squaring those. So this is a double negative, so this should be plus, plus, and this is actually 12 squared, plus negative 3 minus 2 gives us negative 5 squared. Alright, this ends up being 144, and this ends up being 25. And we're going to take the square root of those two added together. So when you add them together, you get the square root of 169, which the square root of 169 is 13. Okay? Now, if it didn't come out to a perfect root, we'd have to do what we did before with our right triangles, but it came out to a perfect root, so we're good. And that's how you do all the problems on this